So acid reactions are important because they can turn up easily on your Year 12 exams. They can turn up as either you're expected to know what the products are and have to do some stoichiometry, or they could be something like an organic reaction, so alcohols are oxidized to carboxylic acid and aldehyde. How you tell the difference between them? Well, the carboxylic acid, you can use one of these acid reactions to tell the difference between it and the aldehyde. So there's all sorts of different ways they can sneak this in. And so make sure you know it even from the early years, because they come up in the exams in the early years. And so the first one here is acid plus base, gives salt and water. And so the technique here too, by the way, of testing for the acid and the base is not to contaminate it with a indicator, but you can just get a drop out and you can test it for an acid, which is pink, and later on we'll test it. And when we've sort of overshot it, and we've not only just neutralized it, but we've put too much in there, so now it's become excess sodium hydroxide and basic, and we'll pull that our little bit out there and we'll test it and it'll be blue. And so notice that for all of these equations, they're also exothermic, as well as the pH. So you can see the pH is the blue one and the green one is the temperature. So the temperature always goes up when we put these reactions together, and the higher the enthalpy, the more extreme it is. And so this one here is the magnesium. Now this one here takes forever to react. As you can see, it has a huge enthalpy, but the temperature is not going up. And I fast forward this at 10 times speed and it's still not getting there. So the temperature is not going up a lot. It'll end up giving steam. You'll see when we do the pop test, it really gets super hot. And the neutralization is very, very slow. It's only creeping up. So we'll skip that one and go to the last one. So acid plus carbonate gives salt, water, and carbon dioxide. This one here doesn't have a huge enthalpy, so temperature goes up just a little bit, and the reaction's quite good because it's a powder rather than just one hunk of magnesium with a very dilute acid. And you can see that it reaches pH 7, and the temperature goes just a little bit. Now you can test for the gases as well for these acid-base reactions. So the first one here is the metal magnesium. Acid plus metal gives hydrogen and salt. And what you do is you collect the hydrogen gas, and you can hear when you light it up, the oxygen reacts with the hydrogen, makes a little explosion and gives off water, and you can hear the pop. And then lastly, the carbon dioxide you can test for by putting it through lime water, which is calcium hydroxide. That's a precipitate reaction because you have an aqueous, usually two aqueuses to give a solid. This is an aqueous and a gas to give a solid, calcium carbonate, so it goes cloudy. So that's the test for the carbon dioxide gas. So make sure you know those three reactions. They will pop up all over the place and are expected to be memorized. So a major reason to learn the acid reactions is it moves on to how to make a salt. So salts like ammonium nitrate are fertilizers, which is the reason why we have like 9 billion people on this planet. So there's endless uses for salts. And so this is how you make salts. There's three ways. One's when they're all soluble. The other one is if you've either got an insoluble product or an insoluble reactant. So I'll just show you how to go about each one of those. So first of all, when everything's soluble, so we're going to call that just all soluble. So you start off with the titration. Now you need to work out what the concentrations of either of those two are, and then you can accurately give the correct amounts of product of the two reactants, so it is completely neutralized, so you just live with product. Once you're left with product, you then can just evaporate the water off using crystallization. Now you could just let it evaporate naturally, but if you're doing it quickly in the lab, This is one way to do it, so you can heat it gently. So you've got the beaker underneath to make sure it doesn't get too hot so it doesn't splatter, and that provides the gentle heating. And the cover glass at the top allows it to crystallize, remove the water, and there you have your purified salt. So the next one is the soluble product. So you basically have two aqueous solutions. It's a precipitate reaction, and so that will then need to be separated from the water. So what you do is you filter it, and so you get all of the liquid out of there, and then you can see at the bottom it should be completely clear, but it's a little bit yellowish. Once that dried, you can do several washes, and so that all you're left with is the nice, clean, pure. And so hopefully that explains in part why we teach you all these separation techniques. So that's how you get a soluble product. Now, insoluble product. Now, an insoluble reactant. So this one, it could very well be a powder. And this one, I've just grabbed a piece of magnesium for convenience. And so it reacts with the acid. When it's fully reacted, you need to make sure there is still powder or left over. So you know that all the acid's gone and you've just got the salt, pure salt. And so what you do there is you simply filter it off. And so all of the leftover excess powder, and this is a chunk of metal in this case, it's left over. And the nice, clean salt is left at the bottom. And that's how you make all the three salts, depending on whether the product is insoluble, reactant is insoluble, or whether they're both soluble. Using a combination of titrations, crystallizations, and filtrations and washes.